Hello, my name is Dr. A.J. Coomer, PhD, he, him. I am the smartest mathematician who's ever lived. You know the drill. Alright, this is the first proposition we've encountered in a while that's actually new, which is sort of a converse of the last one. So, what this says, this is, I don't know how to do a GeoGebra of this because this is, I kind of looked at this. This is a proof by contradiction. So again, there's basically two types of proofs in mathematics. You want to prove proposition X. You can either prove directly that X is true, which is called a constructive proof, or you can do an indirect proof or a proof by contradiction, which is you assume that X is false and prove something that's impossible. Therefore, X must be true. And these are two basic yeah. Okay. So equal triangles which are on the same base and in the same side are also okay. The point being is that most of the difficulty we've had with Euclid has been the type of proofs where he says, okay, imagine this impossible situation and I'm going to explain why it's impossible. And it's really hard to imagine something that's impossible. It is literally beyond your imagination. So imagine something unimaginable, and then let's explain why it's unimaginable. Well, by definition, it's unimaginable, so it's really hard. Anyway, so let ABC and DBC be equal triangles. Now, what does equal triangle mean? Are they congruent triangles, or does equal triangle mean equal area? See, this is an issue in math. In math, congruent is a weaker word than equal. So there are many things which are, all things that are equal are congruent, but not all things that are congruent are equal. In the same way that every square is a rectangle, but not every rectangle is a square. But here, I think all congruent triangles are equal, but not all equal triangles are congruent. I think that's the way that the verbiage is being used here. So they're on the same base and on the same side. So this is a partial converse of 1.37. So equal base, because here we could, not sure. This is saying that all triangles that have the same base and height have the same area. And, and this is saying all triangles with the same base and the same area also have equal height. Okay. Let ABC and DBC be equal triangles which are on the same base BC and on the same side of it. Okay. Join AD. Cool. I say that AD is parallel to BC. If not, draw AE through the point A parallel to the straight line BC. Yeah, okay. And join EC. Therefore, ABC equals EBC by the previous theorem, by 1.37, okay? Because they're on the same base and in the same parallels. Same base, same height. So, but ABC equals DBC. So either the reasoning sort of implies basically we either have this smaller triangle, which is a strictly smaller triangle inside of this bigger triangle. So the way that it's drawn here is that this triangle EBC is strictly smaller than this triangle DBC. The other option is that we have E out here, in which case EBC would be strictly bigger than DBC. But all that matters is that one of them is clearly bigger than the other. I did look at this a little bit. One of these two triangles is clearly bigger than the other. So the triangle EBC is clearly bigger than the triangle DBC, or clearly smaller than the triangle DBC. What matters is that they are clearly not equal. One of them is clearly greater than the other in terms of area. because this would say that ABC, so, oh, God damn it. My sweetheart. Come here, sweetie. All right. Hi, sweetie. Hi, baby. So, anyway, I lost my train of thought. So, ABC and DBC, we assumed that these are equal triangles. Okay, now what we do is we construct this additional triangle, EBC, which such that it has the same area as ABC. But we know that either EBC has a strictly lesser area than DBC, or it has a strictly greater area than DBC. But we've proven also that it has the same area as DBC. So we assume an impossible situation. We say we're assuming that the proposition is false. So assume that we have D out here that has the same area as EBC. Okay, I think I know how to do that. I think I actually know an interesting way to do the GeoGebra. Okay. Hi, sweetheart. So, sorry, I'm distracted because I have to satiate the cat. You want to hear her purring. So, well, let me turn the noise gate off so you can hear the cat purring. I figure there might as well do like an ASMR thing. Hopefully you guys can still hear me. Looks like the waveform is bouncing, so. Anyway, I think the idea here is kind of clear. Maybe I should write it out in the description. But basically, assume that there is a triangle. Actually, let me start doing this. Let me write this out. Hi, sweetie. Cat's rubbing her cheek on the microphone. Hi, sweetheart. Yes, you're the best. Now there's cat hair all over my microphone. Are you happy? Let's oops. Let's go over here. Let's start writing this out. This is 39. Okay, element page. Okay, so let ABC and DBC be two triangles with equal area. This is step 1. 2, suppose DBC AD is not parallel to BC, i.e. the triangles have equal area and equal bases, but different heights in modern terminology. Oh, shit. That's right. Okay. Three. Okay. Suppose AD is not parallel to BC, so they have equal area and equal bases, but different heights. Our goal is to show, i.e., goal is to show the triangles, i.e., the triangles have equal area and equal bases but different heights. Our goal is to show this is impossible. 4. Construct AE. Construct E along the join. Construct E incident with join of B and D such that AE is parallel to. Construct E incident with the join of B and D such that A times E is parallel to, or such that, let's call this tri of angles A, B, and C be two triangles the triangles. Suppose join of A and D is not parallel to the join of B and C. Our goal is to show this is impossible. Construct E incident with the join of B and D such that the join of A and join of B and C. Okay. 5. Because tri A, B, C and triangle E, B, C the same and at the same height, because triangle ABC and the triangle EBC have the same base and the same height, because the triangle ABC and the triangle EBC have the same base and the same height, they have the same area. 6. However, either area of the triangle EBC is less than the area of the triangle of DBC. Either 6A, one of these two are true. One of these two things is true. Oh shit, sorry, I should blow this up so you can read it. Forgot about that. Let me go over this again. So, let ABC and DBC be two. Okay, let's have these as the same. ABC and DBC be two triangles with equal area, that is, equal bases. What's the cat doing? Our goal. Hi, sweetheart. Our goal is to show the triangles have the same height. So, suppose the join of AD is not parallel to the join of BC. i.e. they have equal area and different heights. Equal area and equal bases, but different heights. Our goal is to show this is impossible. So construct E here incident with join of B and D. Mitty, shut the hell up. Such that the join of A and E is parallel to the join of B and C. So we're assuming AD is not parallel to BC. Okay. Because the triangle A, B, and C and the triangle E, B, and C have the same base and the same height, they have the same area. So these two triangles, ABC and EBC, they have the same base and the same height. It doesn't look like it in this diagram. However, they have the same area. I think better would be if we swapped D and E here. That might be a more clear diagram. Anyway. Sorry, let me... Would maybe be clearer if we swapped D and E here. Because they have the same base and the same height, they have the same area. However, either the area of EBC is less than the triangle of DBC, as shown in the diagram, or it's greater, which would be the other case. Ah! God damn it, I have fucking caps lock on. Let me turn on line numbers. Okay. However, as shown in the diagram, or it's greater than. Okay, or the area is greater than. Okay. So we have proven 7. We have proven all of area of tri ABC, right, area of the triangle of DBC. Assumption. By assumption, the area of the triangle ABC is equal to the triangle EBC by construction. By assumption, by construction, the area of the triangle DBC by construction. Therefore, the situation is impossible. All right, 8. It is not possible for there to exist two triangles with equal area and equal bases but differing heights. Awesome. Okay. Yeah, okay, so this is a partial converse. Only... What is your problem? Come here, sweetie. Come here. All right, I'm going to pick you up then. Jesus Christ. Cats they're like women, which is that the more they complain, the happier they are. All right. Because the two triangles ABC and DBC have to be on the same side of the line BC. If they weren't, then of course AD would not be parallel to BC, but oh right, would not be parallel to BC. I see. Jesus Christ. Use of proposition 39. This is used in 6.2. All right, am I gonna really try to do the GeoGebra with this cat here? All right, I think I'm gonna pause the video and do the GeoGebra later. So what I'm gonna do is I'm going to have DBC be a completely free triangle. But what I'm gonna do is take this join DB and make that a long line, and then say, okay, the meet of DB with the line A, with the parallel line of A, that triangle is going to be EBC, and those are obviously going to have the same area. And what I might do is show off the thing. Okay, this doesn't work if they're not in the same parallels, but we can also do the base and height thing. Okay, I got to think about this a little bit. I am going to deal with this cat. This one I'm actually looking forward to. This is going to be fun, but I got to think about it a little bit. All right, I'll see you in a little minute. Bye. All right, I'm back. So let's just start here. Okay, so we don't actually need these compasses, do we? Because this isn't about area. It is about area, but we don't need the parallelograms. These don't matter. Okay, so I'm actually going to delete this as well. So we just have this triangle. This is ABC, okay? And it'd be nice, if we could, but I don't feel like doing the copying procedure again, because that's just a pain. We could, but I'm not going to. So I'm going to keep this in the parallel of A. Okay. Now what I'm going to do, I'm going to take this free point and take this free point okay, this is going to be D. We're going to show its label. Okay. And we're going to take this triangle this triangle. We just wanted to match. This is 5. Is that right? Okay. Okay. Okay, and now what we're going to do, we're going to take this line, the join of B with D. Take this, and we're going to call it the join of B and D. This is the join of B and D. It's going to be green. Cool. Does that work? Yeah, let's just go with that. the join of B and D. Okay, and this is E, which is the join meet of I'm going to call it E. See what I'm doing? I think this should actually be that blue. That way we have good contrast, honestly. And it looks nicer. There we go. I think that there's a better way to think about this. I don't know. Alright, I think this is good as far as the GeoGebra is concerned. I will see you in the next video. Thank you for watching.